Hi guys, and welcome to the Elevate Academy YouTube channel, where we will be helping you guys get through all your academic hurdles. Okay, let us start off with some basics of math, being the exponent laws. Basically, almost all of algebra is built on these concepts. And if you do not have these basics nailed down, the rest of the work becomes quite difficult. So let's start off with the first one, the product of powers rule, where very importantly, you see these words in bold. And by the way, if you require this PDF, we'll have a link in our descriptions where you can download it. So when multiplying powers with the same base, very important, same base, we cannot do anything with the powers if they aren't the same base. We add the exponents. So as we can see in our examples down here, x to the power 3 times x to the power 2, then only when we realize that we have x and x, that's the only time we can actually add those exponents, 3 plus 2 and x to the power 5. We can do the same thing if we have a number instead of a variable. 5 to the power 4 times 5 to the power 3 is equal to 5 to the power 4 plus 3, and that's equal to 5 to the power 7. So very importantly, when we're multiplying, so we must have a multiplication, same base, then we add the exponents. Now it's very similar when we come to the quotient of powers rule. The only difference here is that when we are dividing, we still require the same base. We still require the same base, but when we have the same base, in this case, we subtract the exponents, as we see here. Y to the power 6 divided by y to the power 2 is equal to y to the power 6 minus 2 is equal to y to the power 4. So all very relatively simple. And this is just the core of the laws. Obviously, they look a bit different when we're applying them in the exact examples. So let us scroll down. Okay, let us look at the power of a power rule when we are raising a power to another power. So here, we don't really worry about the base so much. So as we see this example here, when we are raising a power to a higher power, whatever's within the brackets, we multiply it with whatever's out of the brackets, the exponent out of the brackets. So in this case, we have x to the power 2 raised to the power 3. And how we actually deal with this, we say x to the power 2, what is found within the brackets, times the 3 that's on the outside, and that is equal to x to the power 6. So all very relatively simple. In the next video, we will be going through some examples where all these rules are integrated. So when we look at the fourth rule, I mean, the number of these rules don't really matter. It's just that you understand how to use these rules. And also another thing that's important to understand is that all these rules are reversible, meaning we can go from here to there or from there to there, depending on what the problem requires us to do. So when you look at the power of a product rule, we distribute the exponent to each factor inside the brackets. So in this case, where we have a, b in here, and we're raising to the power n. So remember the power of a and b is 1 and 1. So when we multiply a 1 times n, we get a to the power n, and b, the exact same thing, b to the power n. So in this case, we will do an additional example here. So if we look at it, if we add a to the power 2, b to the power 3, c to the power 4, and we are raising that to the power x plus 1, something a little bit more complicated. I mean, nothing really is complicated because we just apply the rule exactly how we see it. So according to this rule, what we will do, let's just write down our first base being a. So a to the power 2 into x plus 1 times b to the power 3 into x plus 1 times c to the power 4 x plus 1. So very simple, we just apply this rule exactly how we see it. The 2 times there, 3 times that, and 4 times that. So all these are multiplied. And then obviously now we just open up our brackets. So a to the power 2x plus 2 times b to the power 3x plus 3 times c to the power 4x plus 4. So very simple. We just apply this exact same rule. What's important is that we make sure we keep track of these rules. I mean, sometimes by adding more terms here, it can look very confusing, but in essence, we're doing the exact same thing over and over again. And it's not really going to be much different, even when we integrate all of them together. We just need to identify which rule we need to use and which rules are going to help us, and then move forward from there. Okay, so let's move on to the next one. Okay, so the power of a quotient rule. Again, quite self-explanatory here. We can see what's happening here. And when we look at this, basically we're raising the numerator to the power that's outside and the denominator to the power that's outside as well. So as we can see illustrated in this example here, what we need to remember and not forget is that x to the power 1, y to the power 1, which is why we get that. And then let's just try and do another example that might be a little bit more confusing. Okay, let's raise that to the power 3n, and this is a 2. Okay, so let's look at this. Same thing, nothing complicated. We're just gonna change this a bit. 8 squared b raised to the power 3n over x y squared to the power 3n. And as we go forward, we're gonna see like now we're gonna apply the previous rule to this in the exact same way. We're going to multiply that there and that there. So we're going to be having a to the power 6n to b. Remember, this is b to the power 1, where we don't see anything. We know that it's to the power 1. So a to the power 6n, b to the power 3n over x to the power 3n, y to the power 6n. So still, it's important that we break it back down to the basics and apply the basics to our problems. And we must be able to identify how to exactly which rule we need to use to solve each problem. And the only way we get better at that is by practicing and doing as many examples as we can do. So the next one is probably the easiest one. Any non-zero base raised to the power of 0 is 1. So these examples are quite self-explanatory. I mean, you can have anything. You can have anything as long as it's not equal to 0 to the power 0, and we're going to get 1. So that's quite simple. Okay, so for the last one, let's look at this, a negative exponent rule. And I think I've seen most students actually have an issue with this. So we're going to be spending a bit of time on this one. So we say negative exponent means take the reciprocal, but more simply, we'll be able to see it in these examples that what we're actually doing. So if you look at the first example, and if you actually observe what's happening at this, is actually, sorry, this is actually over 1. And once we begin to see this, we begin to understand this a little better. And what we're actually doing here is, a good rule to remember here is that when we look at our rule, when we are moving something from the top, from the numerator to the denominator, or from the denominator to the numerator, as we'll see in this example, all we do is we change the sign of the exponent. Again, very importantly, where our base is not equal to 0. So as we see in these examples, the first one is actually 2 to the power minus 3 over 1. But we do want to move this to the denominator. And we can do that because there's only one term here. there's no addition or subtraction on either side. So that is the only time we can do this is when there's a singular term on the top. And so when we move this to the bottom, we actually get 1 over 2 to the power 3, because what we've seen is that when we move this to the bottom, the exponent changes from a negative 3 to a positive 3, and then we can further simplify this to 1 over 8. In the second example, very similar, we have our base being x to the power minus 2. And when we move that to the bottom, so another way we might wonder, hey, how does this 1 come here? There's actually a 1 here, which we don't usually write. And it's 1 times x to the power minus 2. So when we move the x to the power minus 2 to the bottom, it becomes x to the power 2, and we're left with the 1 on the top. So 1 over x to the power 2. And the third example, I've noticed a lot of people get confused with this, and then they would, yeah, this can be a bit confusing. But what we need to remember is that when we are moving this p to the power minus 3 to the top, we actually have a 1 here that remains, okay? So when we move it to the top, it becomes 2 times p to the power 3. Obviously, everything over 1 is just itself, so we don't have to write the over 1 anymore. And so we have 2 times p to the power 3 and 2p to the power 3. What's important is to remember that this 2, nothing happens to it. We just leave it exactly how it is. So I would add another example here, and let's just see how this is different. Is if we had something like this, 2x to the power minus 4. So how we would treat this, we would separate the 2 and the x. So it'll be 2 times x to the power minus 4. That'll be our first step. And then we would say that is equal to 2 times 1 over x to the power 4. Now, I've seen many students go and straight away from this just say, okay, we have a negative 4 exponent there, so that's equal to 1 over 2 x to the power 4. And that's completely wrong, because this 2 has its own power, which is 1, and that's a positive exponent. So if you had to put the 2 in the denominator, what we would actually have is something like this. And there'd be no need to actually do that. So it's important to remember that we treat each of these separately. Okay, so we just want to get rid of all these. Okay, so the 2, we don't have to do anything with that because it has a positive exponent, and we're perfectly happy with that. So 2 times x to the power negative 4, and it's equal to 2 times 1 over x to the power 4, which is actually equal to 2 to the power, sorry, 2 over x to the power 4. I hope this video helps you and helps you get over any problems you had with the rules themselves. Please stay tuned for the next video, where we'll actually be going over a few examples where we are now using these rules to solve more complex problems. If you have any questions, please leave them in the comments below. And if you guys require any additional assistance, one-on-one assistance, please feel free to reach out. Our contact details will be below, where you can get personalized lessons one-on-one, and each lesson there is recorded as well and sent to you so you could use them for future reference. Thank you.